Hello everyone, good morning. How are you all feeling today? I trust you're all well. My name is Alan Cantos and I'm originally from Philippines, and you know what? The fact that Singapore and Philippines are neighboring countries? This is my first time in Singapore. By a show of hand, how many of you in this room come to Singapore just to attend this event? This event will be one of a key milestone in my career that I will never forget. And for this, I would like to thank our committees in advance for the opportunity of being on stage. It is such a great honor and lovely to be here. Please allow me to give you a quick background about my career history. I started as structural CAD detailer checker from a local outsourcing company in the Philippines before deciding to go abroad, where my first overseas assignment was in Saudi Arabia as designer site engineer. Anyone here who have been to Saudi Arabia? After 3 years in the company, I moved to another contracting company as a structural CAD technician and was promoted to junior structural engineer a year after. After 2 years in the company, I moved to Doha, Qatar and found a job as a structural engineer. It did not last long because of company sponsorship issue. Fortunately, a week before finally leaving Doha, I got a call from an international engineering consulting firm based in Dubai, United Arab Emirates. And that's where my Revit, back in Revit 2008, journey began. After for almost 7 years in this engineering consulting firm, I joined Rumble, stayed in Rumble Dubai temporarily, and then moved in the UK 6 months after. Rumble is one of the international engineering consulting firm with 300 offices and 13,000 employees across the globe. And Rumble ranks 5th on the Construction News Top 10 Engineering Consultants as of January of 2018. Few weeks ago, just by accident, I came across one of the TED Talk speech about the surprising habit of original thinkers, and what hooked me to continue listening to this speech was when the speaker mentioned about, and I quote it, "You don't have to be the first. You just have to be different and better." End of quote. There seems to be a relevance to what I will be presenting to you, because my presentation started from curiosity to an existing process used in sales. This curiosity leads to an insight. It leads me to see something valuable about it, which I can apply in my discipline, in my industry, in our industry. By developing the process using the available tools we use in our day-to-day work, I came up with a workflow which I'm already using in some of the projects I am involved with. Today's session, we will be talking about structural data mining using Revit Dynamo PowerBI workflow, a workflow that I am more than happy to share with you all. So this is our agenda, and by attending this session, you will learn first, the process of preparing the data you need using Revit schedules. I bet this part is the easiest one for all of you. Nothing is so much exciting about this. Next, since Power BI works smoothly with Microsoft Excel, we will use Excel to store our data mined information from Revit. After that, we will create a simple Dynamo graph to automate the process of sending the information to our spreadsheet, thus eradicating potential human error caused by copy and pasting or manual typing. And finally, we will bring our data to life using Power BI. You will all gain a basic understanding on how to build your Power BI project. I will do my best to finish the live demonstration 10 minutes early to allow for Q&A. However, if we run out of time, I'll be around after the session. Just grab me and let's have a chat if you want to clear some things up, if that is okay with you. Alright, let's begin now to the main event. Let's jump now to the Revit model. So for this demonstration, I will be using Revit 2017. So here is our structural Revit model that we will be looking at. And the data that we will be extracting from this model is the weight of the structure. Allow me to examine first what are the element categories available in this structural model. While we can see what are those structural element categories that contributes to the weight of the structure, let's open Microsoft Excel. open a blank workbook, and we will list them down one by one. We will start by giving our column a header or title, as this is very important when you come to import this spreadsheet to Power BI. Let's call it element types. And we need another column for weight in tonnage. Let's call it weight in tonnage. You can add more columns as the project progresses from one stage to another, but for now, we will keep it simple. Alright, the first element type is the floors, so let's call it concrete slabs in our spreadsheet. Next, for structural columns, we will split this into concrete columns and steel columns. Similarly, for structural framing, we will split this into concrete beams and steel beams. I will explain later why this is necessary. Next, we have walls, and finally, we have foundations. For foundations, we will not include the piles, only the foundation slabs if any, and the pile caps. Once you're happy with the list, the next thing we need to do is to convert the columns into table. This is one of the important steps in getting your spreadsheet ready for Power BI import. To convert our columns into table, highlight cells A1 to B8 and press Ctrl T on your keyboard. Ctrl T as in Tango. A Create Table pop-up window will appear, and make sure to tick the box saying My table has headers. Click OK and save your spreadsheet. After that, we are ready to begin in creating the schedules. Let's start with concrete floors. In the project browser, right-click on Schedules/Quantities and select New Schedule/Quantities. Search for the floors and call it PBI-Structural Floors Weight Schedule. The reason why I'd like to add PBI prefix to our schedule is for us to easily identify that this schedule is for Power BI use. Click OK. Under Fields, we need the type and the volume. Next, I will create a calculated value and call it element weight by volume in kilogram. And the formula for that will be volume times the unit weight of concrete. In this case, I will be using 2,400 kg per cubic meter. As my tip to you before you carry on in calculating the weight of the structure, check with your design engineer first if he or she is happy with the unit weight value, as some engineers would like to increase it to give allowance for reinforcement weight. Next, click OK. There will be some inconsistent units error in the formula, and to solve that problem, we must divide first our volume to 1000 cubic millimeter before multiplying to the unit weight of the element. So in that case, let's modify this one as open parenthesis, volume divided by 1000 mm, multiply by 1000 mm, multiply by another 1000 mm, close parenthesis, another close parenthesis, times 2400. Click OK. Filter, you don't have to do anything here. Sorting, you can sort by type. You can keep that itemize every instance check. A little bit of tidying up under formatting. I would like this to be right justified and fixed to 3 decimal places. Click OK. Under Appearance tab, make sure that you untick this box, otherwise it will create problem when you come into the Dynamo section. So let's untick that one and click OK. And we're done with our first schedule for structural floors weight. Next, let's create a new schedule for structural columns. Search for structural columns. and call this PBI structural columns weight schedule. Click OK. Under fields, I need my type, volume, and type comments. The reason why we need another parameter, which is the type comments, is for us to use this parameter to assign which elements are concrete and which are steel. Next, I'll be creating a calculated value parameter and call it element weight by volume in kilogram. The formula will be the same as volume divided by 1000 cubic millimeter, close parenthesis, multiplied by the unit weight of an element. Click OK. Under filter, you don't have to do anything here yet. Under sorting, you can sort it by type. You can tick this off. Under formatting, a little bit of tidying up, make it right justified, and fix to 3 decimal places. Under appearance, which is a very important step in preparing your schedule, is to untick this one as well. And click OK. From here, we can specify that the UC is on steel, and these two here are concrete. The 400 mm diameter column is concrete, and the 750 mm diameter column is also concrete. After that, we can duplicate that schedule and rename it as PBI structural RC or concrete columns weight schedule. Now, under filter tab, you can filter it by type comments, which is equals to concrete, and you're done. The reason why you can't see any values in the element weight for column 400 mm diameter is because one column value is different than the other of the same type. That's because they are of different length. You can go back to sorting and tick itemize every instance to see the weight for each individual element. Next, you can duplicate this one and call it PBI structural steel columns weight schedule. Let's rename this. Instead of RC, change this to steel. Under filter, change this to steel. Next, jump back to the fields tab and we will update our formula for the calculated value. The unit weight of steel we will be using is 7,850. Again, double check with your design engineer if he or she is happy with the unit weight of steel you are planning to use. This is also the reason why I need to split concrete to steel, because the unit weight of concrete, which is 2,400, is different than the unit weight of steel, which is 7,850. Click OK, click OK, and we're done with our steel columns weight schedule. Next, structural framing. Create a new schedule, search for structural framing, and name it PBI structural framing weight schedule. Click OK. I need the type, I need the volume, and I need the type comments. I'll create a calculated value and call it element weight by volume in kilogram, and the formula will be volume divided by 1000 cubic meter multiply by the unit weight, which is 2400 for now. Click OK. Under filter tab, we don't have to do anything yet. Under sorting, you can sort it by type. You may untick this one, itemize every instance. Under formatting, a little bit of tidying up, right justified, field, and fix to 3 decimal places. Click OK. Under appearance tab, don't forget to untick this box and click OK. Now, under type comments, we know that this is steel, so let's type it as steel. Click OK, accept the changes. 300 by 600 mm, we know this is concrete. Accept the changes. Another steel. Click OK. Concrete. Another concrete. And steel. Next, let's duplicate this schedule and call it remove this copy one. So let's call it PBI structural RC or concrete framing weight schedule. Click OK. Under filter tab, you can filter it by type comments equals to concrete. And under sorting, you can turn this itemize every instance on now, so you'll be able to see the weight calculation for each element. There you have it. Next, let's duplicate this RC framing schedule weight and call it steel framing. Go to filter tab, edit that, type comments equals to steel. Go back to the fields, update the formula for the element weight by volume by changing the unit weight from 2400 to 7850 for steel. Click OK, click OK, and we're done with structural framing. Next, for the walls, create a new schedule, walls, and call it PBI walls weight schedule. Click OK. We need a type and we need the volume. And we need to create a new calculated value which is equals to element weight by volume in kilogram. And the formula will be the same as volume divided by 1000 cubic mm first, and then multiplied by the unit weight of concrete, which is 2400, and click OK. Under filter tabs, you don't have to do anything here. Sorting, you can sort it by type, it's fine. And a little bit of formatting, right justified, and fixed to 3 decimal places. Click OK. Under appearance tab, don't forget to untick this box. Click OK. And we're done with the walls. And finally, we have foundations. Create a new schedule, select for structural foundations, and call it PBI structural foundation weight schedule. Click OK. We need to type, we need the volume, and this time I need the comments. I will be using comments parameter to specify whether a member is a foundation slab, a pile cap, or a pile. Click OK. From here you will see it's already arranged as pile cap, pile, Do I have foundation slab? Seems I don't have any foundation slabs, just pile and pile cap. Go back to the fields tab. I'll need to create a calculated value, which I will call element weight by volume in kilogram. The same formula, volume divided by 1000 cubic mm, and then multiply by the unit weight of concrete. Click OK. Under filter tab, you don't have to do anything here yet. Under sorting, you can sort it by type, that's fine. Leave this itemize every instance tick. Under formatting, a little bit of tidying up, write justified, and fix to 3 decimal places. Under appearance tab, don't forget to untick this box. Next, let's duplicate this one. And call it structural foundation. We'll keep it pile cap. PBI structural pile cap weight schedule. Click OK. Under fields tab, filter by comments equals to pile cap. And we're done with the first part of preparing our data using Revit schedules.